Welcome, class. Today we're going to be looking at section 9.5. I'm assigning it today, Friday, April 24. It'll be due next Wednesday, April 29. And we're getting down here towards the last ones. Just a quick review of where we've been. Chapter 9 has been on second degree equations. That, again, you remember, is where I have a x squared or a y squared or an xy. The general form was ax squared, a could be any number, plus bx plus c equal to 0. Second degree is where this a does not equal 0, because if it did, it would be a linear equation, because if a was 0, that term would drop out, and it would be a linear equation, which we've solved before. So as long as a is not 0, that's some type of second degree equation. You remember we solved by taking the square root of both sides. We solved by completing the square. We solved by factoring. We recognize that it doesn't always work. It's got to have a rational solution. It's got to be factorable. But the quadratic formula would always work. This one always work. This one some of the time, but it's fast if it does work. So we usually try to take a look at that one because it can be sometimes the quickest. For today, I need to review this number 1, taking the square root of both sides, because that's going to lead us into our lesson today. So that's where I'm going with that. I'm going to go kind of fast here because we've done this before. But a real quick one, if I were to solve by taking the square root of both sides. Square root of both sides gives me the absolute value of x, gives me 5. X is plus or minus 5. Square root of both sides, I'm going to kind of take a shortcut here, get the absolute value of x equals the square root of 20. That means x will be plus or minus radical 4 radical 5. That means x will be plus or minus 2 radical 5. When we have a negative, we can only do it if we're allowed to use complex numbers. This gives me the absolute value of x. I would have the square root of 16, square root of the negative 1. That gives me x to be plus or minus 4i. If we weren't allowed to use imaginary or complex numbers, we would have no solution because of the negative radical. This one has a fraction, same principle. Get the absolute value of x. I'm going to have this one to be radical 4, radical 7, radical negative 1 over radical 9. That allows me to reduce that down. I'm going to get 2 radical 7i over 3, plus or minus. This one had a quantity here. Same principle though, square root of both sides. The square root and the squared cancel each other off. They're inverse concepts, so they undo each other. I get x plus 3, end up plus or minus 6. Bring the 3 across, and I end up with a negative 3 plus 6, which is 3. Negative 3 minus 6 is a negative 9. Should check this one out. I haven't been checking these, but if I had put a positive 5 in and squared it, it would have checked. A negative 5 would have squared. Let's check this one out. Yeah, I think it also will work. I plug in 3. 3 plus 3 is 6. Squared is 36. Negative 9 plus 3 is a negative 6. Squared is 36. It checks out. Square root of both sides. If you don't mind, I'm going to take a shortcut and go right to there. Plus or minus square root of 6. Bring the 3/4 across. It's really technically 2 answers here. 3/4 plus radical 6, 3/4 minus radical 6. This one, if I want, I could divide both sides by the 3. not the 4. The 4 is being added or subtracted, but 3 is being multiplied. Because 3 is being multiplied, I could divide everything by 3. These 3's would cancel, and I would get x minus 4 squared. Negative 12 divided by 3 would be a negative 4, and made it quite a bit easier. So I end up with x minus 4 equals plus or minus 2i. Bring the 4 across. And again, I did all 7 of those pretty fast because it was review. The reason I reviewed that is this concept right here. Today, we'd like to also recognize the reverse of what we just got done doing. The reverse of taking the square root of both sides can also be useful. The reverse of taking the square root is to go the other way and square both sides. That's an important concept here for the next 15 minutes or so. This is a legal algebra procedure, because if I have an equation and I square both sides, notice I took both sides and squared them, I still get a true equation, okay? So I can square both sides. That's going to be an algebraic procedure that we're going to look at using here now. Got 3 examples to start off here. When I square both sides, it's also called solving a radical equation. Radical because there was a radical in the equation. The reason I square both sides is to get rid of the radical. Because if I have a radical and I square it, whatever is under here, this square cancels with the square root, and I get whatever is under there all by itself. So squaring a radical cancels the radical off. Squaring this radical will leave x plus 5. That's why we do it. So my first step is to square both sides. As I mentioned up here, the radical and the squared cancel, and you're left with x plus 5. 7 squared is 49 on this side. Bring the 5 across and I get 44. Need to check my answer though. Plug 44 in. 44 plus 5 is 49. Square root of 49 is 7. It will check out. I'll put that right over here once. It's important here to check these out because we do get extraneous roots, extra roots that aren't solutions to the original. 44 put in here would be 44 plus 5. Square root of 49. Square root of 49 is 7. It does check out. So that means that I keep that solution. I check that answer. This one here, I've got some other things that are connected to the radical. Before I square both sides, I need to try and isolate the radical if at all possible. So I begin by subtracting 11. That will leave me 4 times the radical. 31 minus 11 is 20. If 4 goes into 20, I should divide by 4, so I'm going to do that right now. 4's would cancel, and I got my radical isolated. And on this side, it's a 5. Because I isolated the radical, I can now square both sides. Like that. So I have the radical x minus 3 squared and the 5 squared. As I mentioned earlier, the radical squared cancel, so this radical and the squared cancel, and I'm left with x minus 3 equal to 25. Bring the 3 across and I get 28. Better check out our answer, so I go back to my original. 4 Instead of x now, I'm going to put in 28 minus 3 plus 11 equals 31. This becomes 4 radical 25 plus 11 equals 31. Radical 25 is 5. (20 plus 11) does give us 31. It does check out. So that means I can keep the x equal to 28. I checked my answer. This one's got fractions, but at least the radical is already isolated. So I don't have to isolate the radical like I had to do here. So I can immediately square both sides. And again, I know I'm being redundant, but squaring both sides gets rid of my radical. That's why I do it. Why do I square both sides? To get rid of the radical. The radical and the squared cancel. That gets rid of it for me. Gotta be a little careful here. Don't write down 5/3. There was no radical, so I got to take 5 and square it, which is 25. 3 and squared makes 9. A lot of people would have just put the 5/3 down, but it has to be squared. So now I need to bring the 3/4 across. Need to get a common denominator. 36. This was taken times 9, so I take the 3 times 9. This was taken times 4, so I take 25 times 4. And I end up with 73 over 36 for my answer. I should check it out to make sure that it does in fact work. Don't mind, for time's sake, I'm going to leave it, but it would check out in this case. If you would put that in there and add 3/4, you'd get a common denominator, you'd get a perfect square, and it would check out. Same process that I did over here. These are going to get a little more challenging now. We're still going to isolate the radical and square both sides. But the reason these are more challenging is there's another x now, where previously I didn't have anything except numbers there. So now that second degree equation stuff starts coming into play. The radical was isolated, so I could square both sides. Again, the reason I'm squaring it is to get rid of the radical. Notice the radical here will cancel with the squared. I get x plus 6, but over here it is x squared. Again, notice I can now have a second degree equation. I want to set it equal to 0, so I bring the x across, bring the 6 across. Very easy factoring here. X minus 3, x plus 2. Notice then x will equal 3. X will equal -2. But I need to check it out. Let's plug in the 3 first. So here's my original equation. I'm going to have 3 plus 6 equal to x, which is 3. Gives me the square root of 9 equal to 3. That is 3. Does check out. Try the -2. If I put a -2 in, -2 plus 6 is supposed to equal x, which is -2. This gives me the square root of 4, and it's the principal root. Notice that there's no minus out front. These do not equal. That means this is an extraneous root. I only keep the 1 because the solution must make the original true. That's why we check it out, is for those extraneous roots. This one, I need to isolate the radical. I have to get the x out of there. So I bring the x across. it'll become a negative. It'll be 3 minus x. Now I'll square both sides. Why did we square both sides? To get rid of the radical. The square root and the squared undo each other, and I'm left with the 2x minus 3. This though now, watch carefully, this is a FOIL problem. 3 minus x squared. I'm going to put that up here. 3 minus x squared really is 3 minus x times 3 minus x. I need to FOIL that. 3 times 3 is going to be 9. I'm going to have a negative 3x and another negative 3x, which is a negative 6x. And a negative x times a negative x gives me x squared. Make sure that because this was a sum or difference, we had to FOIL it. Important that you pick that up. I've got an x squared here. Take this 2x, bring it over to be a negative 2x, so I get a negative 8x. Negative 3 brought over will be a positive 3 plus 9 is 12. I can factor this into x minus 6, x minus 2, which means x equals 6, x equals 2. But I need to check them out. So let's check out the 6. This would be 6 right in here, plus the square root of 2 times 6, minus 3 is equal to 3. Let's check that out. 6 plus the square root of 12 minus 3. 6 plus the square root of 9. Square root of 9, it's a positive principal root there. Notice it does not check out. So the 6 is an extraneous root. Check out the 2. X is 2, so I got a 2 right there. Square root of 2 times 2 minus 3 equals 3. This gives me the square root of 4 minus 3. 4 minus 3 is radical 1. That is 1. It does check out. So x equal to 2 is a solution that I keep. Sometimes neither one will check out, sometimes one, sometimes both, but you need to check those answers. Same idea here. You need to isolate the radical. Means get the 2x brought across. So I have 8 minus 2x. I just took the 2x over, changed the sign. I then square both sides. The radical and the squared cancel out. Get x plus 1. This side I got to FOIL it again. That would be 8 minus 2x times 8 minus 2x. That's what 8 minus 2x squared is going to be. So I got 8 times 8 is 64. I get a negative 16 and another negative 16, which makes negative 32. And negative 2x times negative 2x is 4x squared. Now I have my second degree equation, no more radical in it. So I need to solve this second degree equation. Got a 4x squared, bring this x across, it'll be a negative 33x. And I have a 1 brought across, which will leave me 63. This particular one also happens to be factorable. Many of you would probably go to your quadratic formula, but I'm going to go with the factors because it does work and it's faster. It's 4x minus 21 and x minus 3. Can check it out. That will make positive 63, negative 21, negative 12 makes a negative 13 or 33. So this 4x minus 21 equal to 0 means x is 21 fourths. Here, x minus 3 equals 0, which means x equals 3. I got two values for x. Got to check both of them out. It's a little involved in that process of checking them out, but let's go ahead and do it once. So I have 2 times 21 fourths plus the square root 21 fourths plus 1 is equal to 8. This will cancel here. 2 will cancel into there twice. I get 21 halves. This will be 4 fourths plus 21 fourths is 25 fourths. 21 halves. Square root of that is 5 halves. This gives me 26 halves, which is 13, and it does not equal 8. So this root gets canceled off. Let's try the 3. So it would be 2 times 3 up here, plus the square root of 3 plus 1 equal to 8. Gives me 6 plus the square root of 4, 6 plus 2, and as you can see, it does equal 8. So I keep that solution. But again, you need to check them out because they will not always turn out to be the same. This next one is a little more challenging. Actually, quite a bit more. Okay? The reason this is going to be more challenging is I have 2 radicals. Okay? Basically, I have to do the procedure twice over. I'm going to show you one here where I've written it out in advance. Here's an original equation that happens to have 2 radicals in it. Okay? It might be tempting to do something like this. This is a mistake. Because it's a sum or difference, that would mean I have to FOIL this out. That would get rid of the radical first and at the end, but I would get a middle radical that is ridiculously large because it would be the product of those. It would be a radical of a quadratic expression. So rather than doing that, the easier procedure is to isolate one of the 2 radicals. I can isolate either radical by taking the other one and bringing it over. So if I take one of the radicals and bring it across, I chose to take this one and bring it over. Notice it's a negative then. I isolated this radical, and now I square both sides. Well, on this side, life's pretty good. The radical and the square cancel, and you're going to have 2x minus 1. But this side, it's a foiling again. It's really 4 minus the radical times 4 minus the same radical. So I'm going to get a 16 minus 4 times the radical, and another minus 4 times the radical. And finally, I'm going to have this radical squared, which is going to eliminate the radical. So I'm going to have 16. I've got 2 minus 4 radicals, which makes minus 8. And here the radical and the squared cancel, so I get x minus 4. Double check where I got all of those expressions from to make sure that you're comfortable with that. Okay? Now here's a key part. I need to re-isolate the remaining radical. Well, this equation has 1 radical left. I got rid of one of the 2. and I got 1 left. So I bring everything over to the other side, isolate the radical. I wish I could divide by -8 here, but I can't because then I would get a fraction. So I'm going to square both sides. This is a FOIL again. It'll be x squared minus 26x plus 169. Here, the -8 squared is 64. The radical and the square will cancel. I get x minus 4. So I get 64. That's a -8 squared. Here, the radical and the squared cancel. I get x minus 4. This side I FOILed. Again, some little heavier algebra going on here, but you need to be able to make those simplifications. Now I'm going to bring everything over to one side. The 64x I'll bring over to a negative. I get a -90. Here I had a -256. When I bring it across, it'll become a positive. With that, gives me that number there. I could go to quadratic formula, but it does factors into those two, which means those are my solutions right here. But again, I need to check them out. If you would check them out, you would find the 85 is rejected. The 5 is kept, if you go ahead and check that out. That procedure is definitely a little more difficult because I had 2 radicals. Definitely more difficult. Review the procedure. Isolate one of the radicals, then square. Then you need to re-isolate the remaining radical and square again. Okay, we're going to try that procedure once right now on a couple of these. I'll fold this over so I have a little more space here. We're going to try both of these. Again, a little more challenging. I could isolate either radical, but I'm going to choose to take this negative and bring it over and make it a positive. So I have the square root of 8x plus 20. If I bring that one over, it's going to be 1 plus that radical. And now I'm going to square both sides. Going to be really helpful over here because the square and the square root will cancel. This one is a sum though. That's a totally different game. That means that I have to FOIL that one. This side easy. The radical, the squared cancel. So I get 8x plus 20. This side, not so much. I got to take 1 times 1. 1 times the radical, another 1 of the radicals. I get 2 of the radicals when I'm done FOILing that. And the radical times the radical will cancel the radical out, and I'll have just what's underneath there, 7x plus 11. Now I need to re-isolate this radical. So I got to bring all this other stuff across. So 7x over here is a negative. I get a 1x. This is 12 right here, brought across will be a -12, gives me 8, gives me 2 times that radical. I really can't divide by 2 because I'd get a fraction here, so I'm going to square both sides. I get x plus 8, 2 times the radical squared. Here I have to FOIL this, so x plus 8 times x plus 8 gives me x squared, 16x plus 64. This side I'm going to get 2 squared is 4. The radical squared cancel out, and I get 7x plus 11. So now I'm going to bring everything over to one side. I get this 28x, bring it across. I believe it's a -12x. Let me just check that once to make sure that I didn't mess that up too badly. Can't seem to find my problem here. Sorry about that. Here it is. Still struggling finding that one. There we are. And I bring this 44 across, and it gives me a positive 20. Then I go ahead and factor this. This part should be pretty easy for us. I'm going to have x minus and an x minus. Two factors of 20, sum of 12, or 10 and 2. Gives me solutions 10 and 2. If you put it back in, you will find both of them actually work. If you plug these back in, both 10 and 2, I believe, will work. So you keep both of them. Don't be afraid to pause this now. Cover up my work. See if you can do this problem again on your own. If not, look back at this. Try pausing it again. Try doing it again until you can do all these steps. This is a fairly involved algebra procedure. One more time through it. Got to isolate one of the radicals. I'm going to isolate the first one. 5x plus 1. Bring that radical across. It will be a negative. It's first step. Second step, square both sides. The radical and the square will cancel, giving you 5x plus 1. Here you're going to have to FOIL that. 7 minus the radical. That means you would take 7 minus the radical, FOILing it 7 times the radical. So you'd have 7 times 7, which would be 49. You got a negative 7 radical, another negative 7, so that makes negative 14 radical 4x minus 3. And finally, the radical times the radical would cancel the radical out, and you would have just 4x minus 3. Again, pretty important step to get from right here down to there. A lot of things can go wrong there. Practice that multiple times until you can get it. Now I need to re-isolate that radical. So bring the 4x across. It will leave you x. This is 46. When you bring it across, I believe it turns out to be a negative 45. Gives a negative 14 radical 4x minus 3. Again, another tough step now. I need to square both sides again to get rid of the remaining radical. Okay, so x minus 45 squared. Here's a negative 14 times the radical 4x minus 3. This is a FOILing problem. So I get a negative 90x. 45 squared is 2025. Negative 14 squared is 196. Radical squared, the radical drops out, so you just have parentheses. And now I got to bring everything over to one side. Take this 4 times 196, bring it over, it'll be a negative. Gives you a negative 874, I believe. Nasty numbers. 196 times a negative 3, that'll be a negative. Bring it over, you're going to add it. Gives you 2613. Again, huge numbers. Even if you go to a quadratic formula, huge numbers. However, they do factor. Turns out the factors are 871 and 3. Who would have guessed, right? But that means your solutions are 871, solutions are 3. You would need to check both of these out. As it turns out, the 871 is rejected, the 3 is not. The 871 will not work, the 3 will. Pretty involved problems. If you can do these two, these are by far some of the more challenging ones in this lesson. Okay. Then I have one final concept here to work through. We'll have two slides here. First one, we're just going to read through some theory. Quadratic form, one of them is like this. Notice the quadratic form, this is my variable squared, this is to the first power. We don't normally write the 1 there, but that's there. That's in a quadratic form, x squared and an x and a minus 12. We can factor, we get solutions 4 and -3. Done that many, many times. But here's now where I'm going to be looking at the form of the quadratic. This x that we have in red right here, in the red equation, could stand for anything. I could put y in there, minus y, minus 12. Could put a y in there. I could put, though, if I wanted to, I could put m plus 3 in there. M plus 3 squared minus m plus 3 minus 12. This is an equation that's in the form of a quadratic because it's got some expression squared, some expression to the first, an integer equal to 0. The x here in red could stand for anything. Could be y's, could be m plus 3's, it could be x plus 1/2. Could stand for anything. I could even let that x be an x squared. Then I would have x squared squared. I have minus x squared instead of minus x minus 12. If it were x squared, just like I factored up here, x minus 4, now it would be x squared minus 4. Just like this was x plus 3, now it would be x squared plus 3. That means the x squared would equal 4, the x squared would equal a -3. Get plus or minus 2, plus or minus radical 3i. And again, we would check our answers. Not going to spend that time around this one, but I want you to get this concept. The form is an expression squared, then an expression to the first. That expression could be anything. Could be y's, could be m minus 3's, etc. Well, now let's take an example of one like that. First thing it says is figure out a substitution. Well, that sounds easy enough, but it's not always so easy. Remember, the form I'm looking for here would be a 2x squared plus a 5x to the first plus 2 equals 0. That's what I'm thinking mentally. Well, what is this? Well, the easiest one is to look at the x here to the first. They have x to the 1/5. So this really is like letting that x, I can write that up here. I'm going to let my x equal x to the 1/5. Okay, so this x to the 1/5, I'm going to let be x. This is x to the 2/5. That's really 2x squared. Because if I put x to the 1/5 in there and square it, that will give me x to the 2/5. That's kind of a hard step for a lot of people to see. Now it's in the form of a quadratic. It will factor. So I'm going to have a 2x and a 1x. I need factors of 2. Gives me a sum of 5. Notice this x will be a -1/2. This x will be a -2. But now keep in mind, we substituted here. The 1x to the 1/5, we let be x there. So that means this x is really an x to the 1/5. This x really is x to the 1/5. A lot of ways to do this problem now, but the easiest way is I want to get this to an x. I need to get that exponent to a 1. The way to do that is I know that that exponent, if I squared it, it would be taken times 2. That wouldn't give me 1. But watch what I'm going to do here. I'm going to raise it to the 5th power. Why did I choose 5? Because 1/5 times 5 is 5/5, or 1. I get x by itself. That gives me the x. This is -1/2 times -1/2 times -1/2 gives me a -1/32. This one I would also raise both sides to the 5th power. This side, 1/5 times 5 is 5/5. I get x. This will be a straight -32 when you multiply it out. You would also want to check it out. I believe in this case they will both check out to be answers, but you have the 5th root of a -32 squared times 2. You could also plug it into your calculator. Take a -32, raise it to the power 0.4 times 2. Here, take the -32, raise it to the power 0.2, and you would get an answer, and I believe they would both check out. This problem, quantity squared, same quantity, but to the first. This is really like 2x squared minus 3x minus 20. Do you see that it's in the same form of the quadratic? So if I begin by letting my x equal this quantity, 1 over x plus 1. If I let that quantity be x, then this is 2x squared. If I let this quantity be x, this is 3x. This is just a straight integer. Again, look to factor it. Have to have a 2x and an x. A little bit more challenging here in terms of the numbers, but we can make this work, I believe. Let's see, once I've done the factoring ahead of time here, I believe it turns out to be +5 and -4, but let's check it out. I get a -20, get 5 and -8, which makes -3. That means this 2x plus 5 has to equal 0, which means x has to be a -5/2. X minus 4 has to equal 0, which means x equals 4. Now I need to resubstitute back out. This x has been standing for 1 over x plus 1. So I got to take that 1 over x plus 1 and put it back in there. 1 over x plus 1. Then I have 1 over x. This will be a -5/2 minus the 1. That gives me 1 over x. This is a -2/2. Gives me a -7/2. A lot of ways I can solve that. I could multiply by the common denominator, 2x, or you could say cross multiply. Just cross multiply there, and I got a -2/7. Here, this x stood for 1 over x plus 1, so I put 1 over x plus 1 in. That means I'm going to bring the 1 across to get 3. Cross multiply, 3x equals 1, x equals 1/3. I believe they will both check out in this case, but you could put them back in, but they will both check out, so we keep all of our answers in both cases. Usually by squaring both sides, you don't have issues with extraneous roots as much as the square root of both sides. That completes our lesson for today. If you remember, I assigned this 9.5 today, Friday, April 24. It is due next Wednesday, April 29. Have a good rest of your day.